Okay, so good day to our monthly science high school students. This is going to be a continuation of our sixth lesson for the second quarter. We have rectangles. Let's try to answer this a bit of a challenging problem. Okay. In the figure below, ABCD is a rectangle, with AB being equal to 20, DA being equal to 15, and AE being the altitude of diagonal BD. So what's the area of triangle AE? So essentially you want to find the area of this triangle here. So how do we find the area of that triangle? Okay, so what we can do first is let's try to solve for the area of this half. The half of the rectangle for this problem. So the area for the half of this rectangle, so that's 1/2 base times height. And since we know that this is a rectangle, therefore DC must be equal to 20 and CB must be equal to 15. Since one of the properties of a rectangle is the opposite sides are congruent and are parallel to each other. So therefore the area of the rectangle is equal to 1/2 of 20, which is the base, and the height, which is 15. So this is going to give us 20 times 15. 20 times 15, which is 300, divided by 2. So therefore the area of triangle DCB is equal to 150. Now, if the area of this triangle is 150, it stands to reason that the area of this triangle is also equal to 150 squared units. Okay? So if that's 150 square units as well, therefore we can solve for the measurement of this side AE by using the Pythagorean theorem. Okay, so how will we do that? First, we need to find the value of dB. So how will we solve for the measurement of side dB for this problem? As you can see, this is a rectangle, therefore all of its angles must be right angles, and therefore if it's a right angle, most likely we'll have a right triangle. So therefore we can say that dA squared plus AB squared is equal to dB squared, and that should give us 15 squared plus 20 squared is equal to dB squared. And using your calculator, so please always use your calculator for these types of problems. So we have here 625 is equal to dB squared. And if you take the square root of both sides, so therefore dB is just equal to 25 for square. Okay, so therefore dB is equal to 25. Now dB here, that's the base of this triangle DAB. Okay, so the base of triangle DAB is equal to 25. And the height of triangle DAB is missing. So how do we find the height, which is 80 for this problem? Okay, so to find the height, since we know that this is a right triangle, and we have here 25 as the area of our figure, we can solve for the value of AE for this one. So how can we solve for the value of AE, or the height? So again, we're going to use the formula for the area of a triangle. So that's 1/2 base times height. And since we know that the area of triangle DAB is 150, we can already equate that as is. 150 is equal to 100. 150 is equal to 1/2. 1/2 of the base. So what's the base of this triangle? So that's 25. And the height is missing. And again, our height is equal to 80, the one that we're looking for in this problem. So to find AE, so that's going to give us, we can multiply both sides by 2, so that we cancel the denominator to the other side. So 300 is equal to 25h, and therefore h, the height is just equal to 12. 300 divided by 25, so that's just equal to 12. Therefore, AE is just equal to 12. AE is just equal to 12. And if AE is equal to 12, and we know that this is 20, we can solve for the measurement of EB. EB is the base of triangle AE. To solve for the area of triangle AEB, we need to get the 1/2 of the base, which is EB, times the height of the triangle, since this is a right triangle. So the height will be 12. Okay, so since EB is still missing, we have to solve for it. And how do we solve for EB? Since AEB, triangle AEB, is a right triangle. It's a right triangle. It can be said, or we can conclude, that A squared plus B squared is equal to C squared. And since we already know the value of the hypotenuse for this triangle, this right triangle, we will have, for this right triangle, our given was 12, right? Okay, so we have here 12. 12 squared plus B squared is equal to 20 squared. So B squared is equal to 20 squared minus 12 squared. B squared is going to be equal to 100, 400 minus 144. Now it's 400 minus 144. So that should give us 256. B squared is equal to 256. And if you take the square root of both sides, the value of B, which is the value of EB, so that's equal to the square root of 256, which is just 16. There you go. So therefore, EB here is equal to 16. Now that we know the base of the figure, we can now solve for the area of triangle AE. So that's 1/2 of 16, the base, times the height, which is 12. Again, that's a right triangle. Your base is not 20 because that's the hypotenuse. Okay? So the base is 12 and the height is 16. So this is going to give us 16 times 12, which is 192, divided by 2. So that should give us an answer of 96. Okay, so therefore the area of triangle AEB is equal to 96 squared units, which is letter 2. Okay, so the answer for our given problem here is 96 square units. And that's how we solve this problem.